Our next speaker, Gary Hoffman, is Director of Technical Services for the PA Asphalt Pavement Association.
So this presentation, many of the presentations this morning so far have been more global. This is going to be very specific, and it's going to be how we in Pennsylvania developed a thin asphalt, hot mix asphalt, plant mix asphalt, 6.3 millimeter overlay for a preservation treatment. I'll bring Neal in here to close out the presentation on some of the stuff that he's continuing to do in this regard. So anyway, this is the outline of the presentation. We're going to talk about how a thin asphalt pavement overlay fits in the preservation strategy, the things we went through to develop a mixed design and evaluation, and I have to tell you that almost everything that we do in Pennsylvania is collaborative between the DOT, industry, and FHWA, and we really appreciate that relationship that we have. I'll talk about the construction of 3 demo projects. We evaluated this mix long term. They're still being evaluated, as a matter of fact, and then some of the results of the performance evaluations. So thin overlays for pavement preservation. When we look at pavement preservation, we look at routine maintenance, preventive maintenance, minor rehabilitation, and all of those improve pavement condition, restore serviceability, and extend the service life of the pavement. All of these, and I have to stress that, are to treat surface distresses, not structural distresses. So things like raveling, things like loss of friction, oxidation on the pavement surface. And we believe that a thin lay asphalt plant mix material fits right into that category. How does this treatment fit with the other treatments from an economic standpoint? And we look at certainly initially it's more costly. You're talking about $4.50, $5 a square yard. But long term, if you look at it from a life cycle cost analysis, it's very competitive, and this research report actually says it's the most advantageous from an annualized cost per mile life cycle. Question: how thick is thin? There are a lot of DOTs right now that have thin lays. That's the nomenclature that NEPPP, the National Asphalt Pavement Association, has applied. They're anywhere from a half an inch to an inch thick. And when we talk about the thickness of a layer in the asphalt pavement plant mix paving layer vernacular, it's all related to the end mass and the nominal maximum aggregate size in the mix. And we always want to be between 3 and 5 times that end mass, the thickness of the paving layer. For the finer mixes, you want to be on the higher side, 4 or 5 times. For the coarser mixes, the base courses, for instance, 3 times the nominal maximum aggregate size. And you want to do that because you want to allow the materials to orientate themselves into the maximum or the optimum configuration under the compactive effort of the rollers. So if we look at 6.3 millimeter, you see that 4 times 6.3 is 1 inch. And that's pretty much where we landed with our work. So one of the concerns, one of the things that we're trying to correct, certainly with any surface, you want good friction. And we talked safety. Where's John at? Is he still here? When John Becker was up here, that's very important no matter what type of surface you put down there. But when you're talking about a flexible asphalt pavement surface, you're looking at macro texture and micro texture. And the difference between the two, the macro texture is really the depth of the exposure of that aggregate on the surface. And of course, when you have a finer mix, an asphalt rich mix, like we do here, and when the thickness gets smaller, that macro texture plays a lesser role than the micro texture, which is really the coarseness and the polishing resistance of the aggregate itself. So in Pennsylvania, we go back a long way, working with the fellow by the name of Dick Howe back in the 70s, put together a 5-level skid resistance level, if you will, on our good aggregates. We have a multiplicity of good aggregates across the state. Some are more polish resistant than others, so we have 5 levels. E is excellent, H is high, G is good, M is moderate, and L is low. We have a lot of granites, crushed gravels that are E's, and a lot of limestones that are L's. But because we're doing a premium mix here on the surface, we selected all E aggregates for this application. So one of the things that we did, first of all, in putting together the mix design procedure and evaluating how these mixes are going to perform out in the field, we had a joint task force, and we looked at probably 12 other states that already had approved mixes, landed on our contiguous states of Ohio, New York, and New Jersey. And the bottom line is we pretty much, I think Ohio and New Jersey have a 4.75 end mass material, even a finer material. We landed on a 6.3 or -1/4 end mass material. Another thing that we did was we wanted to go with a polymer modified PG76-22 binder, 75 duration on the super pave gyratory compactor, and we wanted a virgin mix, no wrapper resin in the mix. So we're shooting, there's what the initial special provision looks like that the projects were, these 3 demo projects were built by. Another thing that we did was we wanted to make sure that we had a well-graded, dense-graded material, and because we wanted the structural stability of that material. So we actually have 6 sieve sizes in that gradation band that have to be met. I know New York, we copied a lot of New York specification. They only had 4 sieve sizes that had to be met, and we felt that created maybe some gaps in that gradation band. So we went to 6 sizes, and that created some difficulty with a lot of our producers in making that material, and I think maybe Neal might address that at the end when he's talking about his presentation. The other thing we did was we had a pretty high voids in the mineral aggregate, the VMA, is 16.5, and that creates a lot of voids now, so we can put a lot of asphalt in the mix, and you'll see that we had 6.8 to 7% asphalt, very asphalt-rich layer. The use guidelines, we wanted to be very restrictive. We only put it on structurally sound pavement. All of these preservation treatments treat the surface. They don't treat the structure of the pavement, so that's critical. It's an alternative to microsurfacing. I was around in the 80s when we brought Ralliumac and we brought NovaChip over from Europe and implemented them here in Pennsylvania. And there's just looking at the different sizes of material. I said they're all SRLE, the best polishing resistant aggregate that we have in the state that we're using, and they're the 3 asphalt designs on the bottom that we have for 3 demo projects, 6.7, 6.9, 7.0, very asphalt-rich material. Here's a look at the 3 gradations that we had on the 3 demo projects, pretty much overlay each other except the primary control sieve, the number 8 sieve, which is the dividing point between the coarse aggregate in the mix and the fine aggregate in the mix. You'll see that the 220, the top line, has about 55% passing the number 8 sieve, and the other 2 about 45% pass. So that the 220 project is a little bit finer, more material passing that primary control sieve. And you'll see that when you look at the friction results on that job, it will make a difference, the finer mix. We wanted to do performance testing on these mixes. You know, when you're doing an asphalt mix, you're always looking at the balance between rutting, too rich of an asphalt mix, versus cracking, not enough asphalt in the mix. And let me tell you, I'm a strong proponent of going to performance testing for asphalt mixture design, and I think I'm really pushing the DOT, and I know that Neal right down here is a leader from the DOT standpoint to move that direction. So we did Hamburg wheel track testing for rutting, and the mixes looked real good. 5 millimeter deflection over, or rutting over 20,000 cycles. Excellent result. And that's what the test looks like. The material's put on a plat and it's pulled apart. It's an excellent test for looking at the cracking, reflective cracking through an overlay. We also were concerned about the performance of the material. We wanted to have an excellent tack coat, and as a result of doing this work, Neal eventually changed their whole tack coat spec, 460 in Pennsylvania. So we did shear testing, looking at the adhesion of the tack coat between the overlay and the substrate. And again, excellent results. This work was done up at Penn State at the Larson Transportation Institute. Good adhesion. We're putting this on the surface. We're going with the premium binder, that 76-22, or the new Massacre 64E specification. I know Neal's going to talk a little bit about the work that he's doing with the PG 6422 binder here. So we revised the tack coat. We went away from, we had an asphalt emulsion tack previously. It was a 50% diluted emulsion. So essentially, we had 33% residue in that material. Now we've gone to an undiluted material, CSS1H, RS1H, which has 67% residue. So going in the right direction. That water doesn't stick too well. So let's look at the construction of these 3 demo projects that I mentioned. There they are in the red dots up through the center part of the state, but some right around this area in Dauphin, Lebanon County, and then some up in Lycoming County up in the northern tier. And the 3 projects were SR22, right between the farm, if those of you from the Harrisburg area, that's the road between the farm show and the ag building. That was directly on diamond ground concrete. We have SR220, that was the Lycoming, the northern tier project. That was on a milled asphalt surface, but that already was a composite pavement. So mine had 4 inches of asphalt on a PCC pavement. The cracks had reflected up, they diamond ground it and put in an inlay on that road. And the third project was an asphalt overlay directly on a flexible pavement surface. So this is the first job that we did. That's the one up here in the northern part of Harrisburg next to the farm show. That's the concrete pavement. There were some corner cracks that had to be replaced. There were some wide joints there that had to be filled, and there were some spall repairs before the road, and there were some full depth patches too. Now, after all this was done, the whole pavement surface was diamond ground tacked, and then the overlay was put in place. And there's what a textbook full coverage tack coat should look like. We don't always get that in Pennsylvania. And there's the mat right after it comes out from underneath the screed, 1 inch thick. This is the Lycoming job. Now I said there's a concern with mat temperature. Why is there a concern with mat temperature? You're only putting the material down 1 inch thick, so your time available from compaction is very short. And we use the PaveCool software. There's an app, you can download that directly, it's free, to predict how much time you have, and mostly we're talking about 10, 12, 15 minutes to get that surface compacted. The material was accepted by certification, the density was accepted by Optimum rolling pattern, but we did take density cores just for information purposes. All the densities were, average densities were 92% of maximum theoretical density and higher. And here's the finished product this is the Dauphin County, the Harrisburg job here. And that road has about 33,000 average daily traffic, so it's pretty heavily trafficked road. The 230 job down in Lancaster County, finished overlay. 220 job up in Lycoming County. So that was right after the work was done. There's the density core from the Harrisburg job directly on concrete, 92 plus average density. So how do these materials look like long term from the typical performance tests from from a friction standpoint, from a ride standpoint, from a rutting standpoint. So let's look at some data long term. And that's the Route 22 job, 45 months after paving. And one thing that we did on this job was we sawed and sealed the transverse joints right out of the chute, but we didn't do anything with the longitudinal joints. Guess what? Next spring we had to go back and seal the longitudinal joints. You're only dealing with 1 inch of material. Those of you who put microsurfacing down, people say, well, we got cracks. Well, of course you have cracks because you're not putting much material down out there. And that's what that project looks like this week. I was out there on Monday and took some pictures, and it looks good, and we'll see shortly that the friction tests and the ride tests also look good. And there's some of the sawed and sealed transverse joints, 7 winters after that material's been down. This is the Route 230 project. You can see that project had been widened. You can see the 2-3 foot widening on the outside there in that longitudinal joint that's created. And that's what it looks like 34 months afterwards. You can see that longitudinal joint. Still, the material's still tight. There's no raveling, no opening of that joint. And that's the 220 project up in Lycoming County, 32 months after paving. And that's a 220 project. I said that was the composite pavement, had reflective cracks, came in and milled and filled it. So you can see the reflective cracks that come back up through the surface. But again, we didn't saw and seal, obviously, but there's no raveling or loss of material at those joints like you see many times. So I'm confident that the overlay mix itself in the construction here is performing well. And I do have to mention, I see Scott's in the back there. We did do a section of microsurfacing, a section of thin lay without fibers, and a section with thin lay after fibers. So what we did see was a delay we got reflective cracks in all of them, but there was a delay in those reflective cracks coming up to the surface. So microsurfacing cracked first, the material without fibers cracked next, and then the material with fibers in it was delayed maybe 20-40% in the rate of cracking. So it performed as expected. So we did skid testing, friction numbers, 40 mile an hour smooth tire, and there's the 22 project. You can see friction before the work was done, about 25, not good. And afterwards, those friction numbers are from 50 to 60, and friction numbers Tuesday of this week, 58 to 62. FN 40, smooth tire. Friction right on target. This is the 230 project, went from about 35 friction number up to 50 to 60, and it's remained there. And the 220 project, that was already an asphalt surface there, had about 45 and friction number, and that remained about 45. We looked at rutting, and this is the 22 project. We had rut numbers about 0.14 inches. The criteria in Pennsylvania is 3/16 of an inch rut depth on a over 10 foot straight edge. So we're within those limits. Here's some real good rut numbers on the 230 project. We had rut depths up about 0.18, 0.2 before, and that dropped down to 0.05, 0.07 inches, and it's pretty much stayed there. On the 220 project, again, a significant drop in rut depth, and typically on a flexible pavement mix, if you're going to get any rutting, that's going to occur very early on in that pavement life in the first year or two, and then it pretty much levels off after that, the total rut depth. Looking at ride quality, and that's one of the primary factors that we measure and that the public wants from us in a new pavement. And in fact, in a pavement life, the longevity of pavement life, you start out, the smoother you start out, the longer you keep it smooth, the longer that pavement's going to perform, because you keep from getting dynamic loading from the truck traffic. And you'll see there that the ride numbers on on the 22 project here in Cameron. We started out, it was initially diamond ground at about 120. Then he did the patches, and we were up to 140 after he put the patches in, so he had to come back and diamond ground the patches. But the overlay dropped us down to about 90 to 100 inches per mile. Higher is worse. Lower is better with ride quality. The current numbers are 95 to 110 after 7 winters in service, and it pretty much stayed level. And then the ride quality on the 230 project started at 160, and we dropped it back to 100 inches per mile, and pretty much stayed level there. In the 220 project, 75 to 85, and dropped that down to 40 inches per mile, and it stayed 40. It's leveled off at that. So great performance on all 3 of these projects. And I'll bring Neal up now, and he can talk about what he's done and the department's done with this with these results, and where we're going from here with looking at some additional information. So Neal Fanin.
Just to give you a little bit about this mix as far as how the implementation has gone in Pennsylvania. I don't think that's represented in these slides. We've had a few districts try it out. A couple of the districts have indicated that they are going to tend to go to this mix rather than the Nova chip, or whatever we call it, you know, the thin mix that they've been using, because this mix tends to segregate less, be less likely to segregate, and is you know, you don't have the problems with delivery that you have with the Nova chip type mixes whenever you have not enough trucks. What we're doing here, this is a kind of a little research project we have going on. There was an interest from the districts right away to have a 64-22 version of this mix available to them. They want to use it where they're doing like cold recycling or something like that, instead of a seal coat type of thing when they have the money. But this mix tends to be somewhat expensive because of the 76-22, so they wanted that option on lower volume road type of things. You can see here it's going to be on low volume roads because of this. You can see that the control 76-22, you're up, this is Hamburg results. You're at 20,000 cycles. You've got around 9 millimeters of rut, which is pretty acceptable. 12.5 is usually where most of the agencies are for their interstate highways, as far as the 12.5 millimeters on the Hamburg test. You can see here that we did a 15% wrap section, and we tight material, and we did just a 64-22 material, and we got 15 millimeters at 5,000 cycles. So we stopped the test at 15 millimeters because it's rutting pretty good, and it's only 5,000 cycles. So it's going to be fairly low volume when we do it. But this was testing we needed to do before we figured out where to go with this. But there is a very significant rutting potential increase when you go away from the polymer modifieds on these finer mixes. We also did delta TC testing, the wrap that we were putting in the mix, and you can kind of see here where you had a pretty decent with the 76-22. You're only 1.7, but getting up to that 5% limit, really close to that 5% limit with only 15% wrap in this fine mix. So be careful. The thing here is, if you're going to put wrap in these mixes, and we're not really planning on doing that, we just wanted to see where we were going, where we could be going in the future, because as you remember from my yesterday's presentation, our producers really aren't I want to say, embracing the fractionated wrap production and stuff. They don't have any interest in producing fractionated wrap. So with this mix, you have to have a fractionated wrap with it. So we're not going to pursue this, but we wanted to see where we were going. And honestly, you got to be really careful with these finer mixes, I think, because the upwards of 5, a delta TC of 5 is not a good result. With these thin mixes, they're a good tool for surface treatment. You can see from what Gary presented that you're going to get quite a bit of IRI help from them, a lot more than you get from other very thin mixes. You can get some fairly significant IRI help from them. Proper base repair is a must. All these projects that we did the demonstration on had very good base repairs and that sort of thing. The friction, you can improve friction if you put good aggregates in them. The minimum, and we didn't have a lot of rut observed, as long as you stick with the polymer modified asphalts. Summary, rapid cooling is a problem. We have had one rapid cooling and proper tack coat application is a problem here, because we've had one failure so far in our implementation, and the district tried to mill off a surface of a road and right away put down the 6.3 millimeter mix. Well, if anybody, if you've been in the field, if you mill a surface, you're better off letting traffic travel that surface for at least a few days, if not a week, to get. You're not going to get it clean enough to get the tack to actually coat properly. You're going to have too much dirt and dust. So the district kind of learned a lesson there. I don't know if they're going to use it again, because districts tend to be that way. But you can see where you're just it's not a good situation if you're going to try to put this on a milled surface. But we've had very good results with this. Districts are starting to go with it, and it's a nice mix for a lot of situations. So, and the other thing is, I suggested I over and over again I told districts, please put this down at about 1 inch. Don't try to cut the bologna too thin, because the 3/4 of an inch is the minimum. But I'd rather see it put down at 1 inch. Not one district has put it down as 1 inch. They've all put it down at 3/4 of an inch. So if you want a higher thickness, you got to specify that, because the minimum is what everybody's going to use, because it's cheaper. Questions?
Just a point of clarification for my edification. The project where you had problems, where you milled and you had some loss of material, that was tacked, correct? They didn't put it directly down without putting a tack coat down.
No, they put tack coat down,
okay.
But they just put it on a milled surface where they had too much.
Yeah. Okay. And was that on one of your subsequent evaluation projects where you did where you used 64 minus 22, or was that a PG 76?
That was just something I got feedback on, because I've been asking districts whenever I contact anybody for feedback on this stuff, and that's the one that we had an issue with, and that really.
Yeah, I was not aware of that.
And you start quizzing people, and you find out, okay, there's this, and this that happened, and that's really kind of what I, blame it on. But I think I'm pretty spot on.
Several of your slides had an acronym on them that indicated it was a thin hot mix asphalt overlay that was used. Can you comment on if it truly was a hot mix asphalt?
Yeah, I might have to defer that to Scott. But anyway, just so folks know, and you may have mentioned this yesterday, that PennDOT is 100% warm mix now, and we most of that 80% of that warm mix is foamed asphalt. But since we also are now requiring anti-strip in all our mixes, that foamed asphalt moving more towards a chemical, because they act as both a warm mix additive and an anti-strip. But Scott, back in 2012, were they warm mix or were they, I think they were
they're
hot mix.
honestly.
SR220 was, I'm 100% sure that was warm mix. It was Evotherm. The first one, I think we were really worried about the cooling rate, so I'm not sure if we...
Well, I think most of the time, if I would suggest anybody, if you're going to do warm mix with this, fine, that's great. It's a compaction aid, but you should do it at hot mix temperatures, because this mix, and I have slides on this I didn't present, but this mix, you have about 10 minutes, even at 70 degrees. At 70, your road is 70 degrees, the air is 70 degrees. You still only have about 10 minutes with this because of the thickness. If you play around with the pave cool, you'll see that it doesn't go beyond 10 minutes very much. So normal, if you bump that up to 1.5 inches, you'll have 20 minutes or so with a inch and a half. So that thickness makes a huge difference as far as how long you have to compact the mix. So that's one of the things when I'm talking to producers and stuff, I really kind of stress is that you don't have a lot of time with this mix to compact it. So
Yeah. I wanted to actually just talk about, I think that the other project you were talking about happened in the Pittsburgh area. That's the other job I think they did.
No, it's up around State College area.
Okay.
The research that I just talked about, yeah, that's around State College.
Okay, because I knew that when Pittsburgh did they weren't part of the study, but they came in late. And originally we wanted them to micro mill it because we were worried about the grooves, because you're only putting it down an inch. So if you have grooves that are a 1/4 inch or more, and they said they had trouble with the micro milling because it was too dusty. And then they proved if they slowed the milling machine down that it would be a better milled surface to put it on.
Well, they just need to clean it really good and probably allow traffic on it for a day or so.
And
you'll be a lot better off.
And the other thing was, I know that on SR220, where we used they used a mix of different aggregate, and that actually failed the Hamburg test, but out in the field, there was no rutting issue at all. I just wanted to point that out because you're only putting it down an inch or less. So I think when you do the Hamburg test, it might not be that's like what, 2 inches thick. It might not really be indicative of what you're really going to get.
Well, it isn't. It's just an indicator of how susceptible to rutting the material is. And when you go from 9 millimeters at 20,000 to 15 millimeters at 5,000, that's a pretty big difference. So we're not gonna allow a 64 minus 22 on any kind of either even you want to say arterials or collectors. It's going to be your lower volume roads, and that's honestly what the districts want it for.
Yeah, I think you need to try it though, because I've heard in New York they screwed up once and they put 64 in where it was supposed to be 76. Like, this is unofficial, of course. And they didn't really have an issue. I think it's because of the thickness. If you did a Hamburg test at 1 inch, then maybe it would be
has a
more
lot to do
indicative.
with the aggregate also.
Sure.
The aggregate structure and the shape of the aggregates and that stuff. I can find aggregates that won't rot, with whatever I have.
Yeah.
But
and one more thing, when we did that test
statewide, no.
when we did that test on Cameron Street, and Gary and I, we were saying this is the acid test because you said to put it on a road that's all stable and everything, and that Cameron Street was like a patchwork quilt of a road. It was patches over here, all different colors and everything. This is a really good mix. 7 years now, and it's even Steve didn't think it would last a year. He threw my own bus, threw me under the bus, but it's doing great. 7 winners, thanks.
I was just curious of I think it was SR22.
Okay.
Just curious of the condition of the slabs before you did the overlay, and then kind of in addition to that, was the diamond grinding due to the condition of the slabs, or was that in an effort to increase the bonding?
I think that was simply to get the surface even, because you're only putting inch on that particular project and an inch down. You're cutting the bologna pretty thin. So if you have a lot of up and down and bumpiness, you really need to take care of that before you start going, because essentially it's just, you know, you're again cutting the bologna pretty thin there, you know. So you'll get a ½ inch here and 1.5 inches here. That's not good. So
that project, the concrete slabs were pretty stable. There were some mid-slab cracks, but minimal. The cracks that did occur initiated at drop inlets and corners and things like that. There was not any vertical deformation over the joint, so that was a good thing. So the platform was stable. The milling was done to restore ride, not necessarily to promote adhesion.
In light of both Gary's comments as well as Scott's, you've gotten 8 years of very good performance. What's the anticipated life that you see on these type overlays, and how many projects has this actually been demonstrated on?
we don't have a huge number. I think the life is highly dependent on the what you're putting it on. So, but honestly, I can see it lasting just as long as any other asphalt pavement. Honestly, because you're putting it down, as long as as long as you design it right and that stuff, you're not going to get a lot faster deterioration in this just because it's thin. If it structurally makes it, then you're good. Yeah.
John, when our task group looked at these other states, the 12 other states, particularly Ohio and New York, they had 10+ years experience on interstates in Ohio, good performance. But I'm sure that the pavements that they put it on were stable and appropriate. And I don't know what they said it's on the interstate. I don't know what the traffic counts were, the truck percentages on that. So I know that 10 years service life is doable. I also know that I was cautioned by my friend Bruce up in New York State that this is a lesser, even with the PG 676, it's a lesser expensive treatment, so it gets overused in places it shouldn't be used. And I'm sure that's true of any preservation treatment. If you don't put it on a good sound substrate, it's not going to perform. And in some cases, it did get a bad name because it was misused. So your comment about, we promote an inch.
Yeah.
And we promote PG 76, and we promote a dense graded mix for stability. Even if you're using the 64, if you have that good long graded, dense graded mix, you're going to get stability.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.